All right, for the second part of this lesson, you're going to need a ruler. Every math teacher has a good ruler. So if you don't have a ruler, you're going to want a straight edge of some sort. You don't actually have to measure anything, so you're just going to need a straight edge of some sort. So here it says we're going to talk about the relationships between the graphs of f and f prime, or the slope of f. So it says, given the function graphed below, graph the derivative of f. And anytime you see this phrase, derivative, I just want you to think of the word slope, like Algebra 1. So it even says, hint, derivatives are simply the slopes at any given point. The part that we really don't like as math people is that this requires some approximation. It's not going to be an exact science. So you've got this function, and I've labeled some of these points. I do want you to move point B to be right on x equals 1. So you can see that I moved mine. It'll make it easier when we're graphing. So here I've got this function of y with respect to x, and then over here we've got y prime, or the slope, with respect to x. So we're going to be using this graph to help us get this one over here. So let's start with point A. We're going to use our straight edge, and you want to try to approximate the slope at point A. So we want it just to touch point A, and then draw in a tangent line. Now I'm going to have to expand mine. Sorry, it's a little bit hard with one hand. So once you've got this tangent line, you now have to find the slope of that tangent line. So I'm going to try to find another point that's kind of nice, and I see that this point is another one that's kind of nice. So I see that I went up 4 over 1. So I would say at point A, my slope was 4. So at x equals 0, my slope was 4. So I'm going to come over here. At x equals 0, my slope was 4. Maybe you approximated it a little bit differently. That's okay. I'm going to plot my slope over here. Now I'm going to go to an easier point next. I see that point C. This one's a pretty easy one for me to do. If I just touch the graph at one point and I want to approximate the slope, see how this one is horizontal? That's a pretty easy one to draw in. Not one-handed. So a horizontal slope has a slope of 0. So I can see at x equals 2, I've got a slope of 0. So I'm going to come over here, x equals 2. This had a slope of 0, and put a point there. Now, where else on this graph is there a slope of 0? I can see another slope of 0 at f. So I'm going to put my tangent line at f. It's a horizontal line, and that was at x equals 6. So I'm going to come over here, x equals 6, slope of 0. Got a few points in here. Now at B, I'm going to put my ruler on B, and I can see that my slope is less steep than it was at A. It's still a positive slope, but it's less steep. Now, I would encourage you to draw this in. It's a little hard for me with one hand, so I'm going to leave it just like this. And I'm going to kind of approximate, and I see that it's crossing from this point to this point. So it looks kind of like we're going up 2 over 1. So I'm going to say at point B, my slope was 2. So at x equals 1, my slope was 2. We've already done x equals 2. I'm going to look at x equals 3. Now I can see that my ruler at D is negative. I'm going in a negative direction. So again, I'm going to pick 2 points. I kind of see it going through these 2 points. So this one and this one. I see it kind of going down 2. It's actually like down 1.5 and then over 1. So I would say it's negative 1.5 at x equals 3. So I'd come over here to x equals 3, negative 1.5. I didn't have you do one at 4, but you can. I would say it's even a little bit more steep, more like -2. And then as I get to 5, and put my ruler there. Now it kind of looks like I'm going down 1 over 1, maybe -1. See how this is not an exact science? We're just kind of approximating slopes. And then at 7, I didn't put a point in there again, but notice that it's now positive again. And I'm gonna really try to get it on there. And I would say this one's up 2 over 1 again. So at 7, I'd go up to 2. Now if I connect the dots here, it's really fun to make noise while you do it. I get kind of this parabola looking graph. Now I want you to think back to the example we did earlier. Example 1, we did something, the derivative of x cubed. Now this is kind of a cubic-ish graph. So I'm gonna put a note to myself here that this is an x cubed-ish graph. And what we found was the derivative of x cubed was 3x squared. This is a parabola type of a graph. So this one is x squared-ish. So we kind of make this connection that because this one was cubic, the derivative is going to be something of a quadratic nature. So thankfully our answer makes sense. Now example 4 asks you to go backwards. And it says, let's try it the other way. So now I've given you the slope graph and I'm asking you to work backwards. And they've given us some extra pieces of information. The first one is f of 0 is 0. That's an ordered pair. 0, 0. The graph of f prime, that means slope, is shown at the right. And then they give us this key here that f is continuous for all x. I want you to take a minute and try to draw this graph with these slopes, starting at this point and making this continuous. The answer will be in part 3's video.